Okay, now we're going to continue with finding slope. And we're going to find slope looking at a line, and we're going to find slope given 2 points. And then we're going to talk about finding slope of horizontal and vertical lines. So this first one is just simply finding slope of 2 points. So if I have 2 points on the line, then I can do my step for my rise and my run. So on my bottom point, I count up. How many is it even with my top point? 1, 2, 3, 4, 5, 6. And then it goes 1, 2, 3, 4. So, and it runs to the right. So it's a positive, or you look at the line, how the line's going up. So it's a positive. So your slope is a positive 6/4, which is reduced to 3/2. And that's your slope. So now what if we have a slope with just we're finding the slope with just 2 points? Well, it's the same concept. You're doing your rise, your difference of your y's, your run is your difference of your x's. So we do our y's first, which is -3 and -7. And remember, it's difference. It's the change. So you subtract them. That's your y's. And mark them off as you use them because it helps. And then your x's, -9 and 7. And you subtract. Now you do the work. So we're going to cancel those negatives. So -3 plus 7 is 4. -9 minus 7 is -16. And then if we reduce that out, the final slope is -1/4. And that's the slope of those 2 points using the difference of the y's, which is rise, the difference of the x's, which is the run. Okay, now let's talk about horizontal and vertical lines. So as you can see on these 2 pairs of points, on this one, your y's are the same. On this one, your x's are the same. So if my y's are the same, think about that. That means that's the top numbers on my fraction. That's my rise. So that means those 2 numbers are the same. So if I'm going to do this difference of them. So 8 minus 8 means that you would get 0 on the top. And then whatever you get on the bottom, so it would be -3 minus 4, which is -7. But it doesn't matter what's on the bottom because 0 divided by anything is 0. So your slope for this one is 0, which means if I were to graph those 2 points, that's a horizontal line. The next one has your x's the same. So again, think about that. You're going to subtract those 2 numbers. So if they're the same, they're going to equal 0 on the bottom of the fraction. And then the top number ends up being 2 minus -8, which is 10. But it doesn't matter again because you can't divide by 0. 0, there's a cheesy little rhyme that helps you remember that. 0 under the line, which is under the division line, is undefined because you cannot divide by a 0. It's impossible. Can't be done. Undefined. And then if I were to graph that, that is a vertical line because the slope is undefined. Whoops, you might want to see it. Okay. All right. Next, we're going to talk about rate of change and kind of it's kind of getting into scatter plots a little bit. Rate of change, the correlation, what's going on the graph. So we have a graph here. Selma is draining her aquarium. So think about that. The water level's going down. The graph shows the amount of water in the aquarium in liters versus the time. So what we have here is time, and then you have water level. So think about what's going on. The water's going down, the time is going. So what is the amount of water in the aquarium at 0 minutes? Well, at 0 minutes means you just started draining it. So that's at its fullest. So 600 liters. That is also referred to the y-intercept, just so you know that. That's what that is. At 0, that's the y-intercept, 600. Now, what's happening to the water? What's happening to the graph? As the time is increasing, the water is what? Decreasing because the water level is going down. Well, as the time increases, the amount of water in the aquarium decreases. So this is one we want. Then they want you to find at what rate is the amount of water decreasing. Well, when we've talked about slope, we've talked about it means rate of change. So it's just like when you're driving in your car somewhere and you're going 30 miles per hour or 60, whatever you're going. That's your rate of change. That's your rate. That's your slope. If you were to graph you driving, your slope is whatever speed you're going. So that's what we want to find, is the speed of how the water is decreasing. Well, at 0, it was at 600, and let's go ahead and say let's do this at 1 minute, it's at 480. So we just have to simply do the slope to figure out how fast that water is going down. The rise from those 2 points is 480 to 600, that's 120, and then the run is just 1 minute. Well, that slope is going down at a rate of 120 liters per minute. And by the way, it's negative. So, and you don't have to put the negative here because you've already described that it's decreasing. So you really don't need to put that because it's asking at what rate did it decrease. It's decreasing at 120 liters per minute. So you don't have to put the negative. Okay, so that's slope. So it's just so you know how to relate it to a slope-intercept form. And by the way, if you were to write this in an equation, it would be 120x plus 600. That would be the slope-intercept form for that equation, for that graph. Okay, so then that brings us to slope-intercept form. This next question, if you're given slope is 1/3, y-intercept is -8, how are you going to put that in slope-intercept form? 1/3 x minus 8. Very simple. Okay, the next one is going to move into point slope form. So we're going to move into point slope. So point slope, if you remember, this is probably the hardest one for students to remember, but it looks like this. So this question up here says, a line passes through the point 4, -9, has a slope of 5/4. So you're going to put, this is your x1, this is your y1. So you're going to put the y1 -9 in. Now, because it's a negative in the equation and it's a negative on the 9, it turns to a positive. And then slope is 5/4. And then again, it's a minus in the equation, but it's a +4, so it becomes -4. That is point slope for this problem up here. Okay? Then it says, write an equation in slope-intercept form for the line. So this one goes with this one down here, number 15. So if I have this picture of this line, so what I want to do is write it in slope-intercept form. So I want to, so I'm going to say, this one went to that one. Oh, wait a minute. I'm reading that wrong. We need to change this one into slope-intercept form. This all goes here. Okay. So let's finish this one out. So we need to change this one into slope-intercept form, which means we need to distribute first. So y plus 9 equals, and then I'm going to distribute 5/4 x, and then 5/4 times 4 means my 4's cross cancel, so I have just a 5 left, -5. And then I have a plus 9, so I'm going to subtract it. And now I can say I've solved this equation for y, which now puts it into perfect slope-intercept form. And this answer now goes to that one. I'm getting off a little bit, okay? Now I can go to this picture. And now this says write an equation. Anytime, excuse me, anytime it says just write an equation, but it doesn't specify point slope or slope intercept, you always default to slope intercept. So we're going to write this one in slope intercept form. I'm going to wipe that out. So we need to write it in slope intercept form, which means we need to find slope and y-intercept. So first thing I'm going to do is find my y-intercept because it's the easiest to find first. So that's my B. So if I look, my line is crossing at the origin. That's my slope-intercept, 0. So now we need slope. And you've already got 2 points identified, so we just do our step. So we rise 1, 2, 3, 4, 5, 6, and we run 1, 2, 3. And then don't forget, we run to the left, which also means your line is going down from left to right. So that is a negative 6/3, which reduces to -2. So now when you put that in your slope-intercept form, B is 0. We don't need the 0, so we clean it up by just writing y = 2x. And that's your final answer for that one. Okay?